third time's a charm. Oh, and now I got the sun setting. So I've been having some issues getting this to work, but I think hopefully this is the one. Welcome, though. Welcome to Video Notes with me, Mr. Swear. I will be your guide through these video notes. Here we are starting Unit 6. Unit 6, we're going to learn about two main things: dilations and similarity. So we'll, of course, talk about those as we go through the unit. Starting with dilation. If you remember back all the way to Unit 2, so maybe I'll change color for reminiscing sake. In Unit 2, we talked about transformations. Specifically, 3 kinds of transformations. Man, that sun is going to drive me crazy. We talked about translation. We talked about rotation and reflection. Right, we talked about these 3, and we actually called them, if you remember, we called them isometric transformation. Because that word, isometric, tells us that they stay the same size and shape. That background content remembering will help us here, because dilation is a non-isometric transformation. I'm trying to think if there's a quick fix I can do to get that sun out of my face. Maybe a little this, that'll work enough. Yeah, so this is what I want you to write. This will be important for you to have. A dilation. This is how we are going to define it. A dilation is a non-isometric transformation that enlarges or reduces the size of a figure. A lot of writing. Here's the nitty-gritty. The really important thing is that when we talk about dilations, we're going to be talking about something. Are we making it bigger? Are we enlarging it? Or are we shrinking it? Are we reducing the size? A big takeaway here is enlarge, reduce. We're going to be using those words a ton. Just one last reminder, non-isometric, that clues us in to the fact that it changes size or shape. But here, we're just changing the size. That's the only thing we're messing with. So I have, paste these in, I have some triangles for us. When we look at a dilation, and I have to be careful, maybe I'll just zoom out a bit. When we have a dilation, well, one thing that's really important to know is what figure you're starting with and what figure you're ending with. Yippee-ki-yay, hooray, hooray. We learned about that also in Unit 2. When I put these little marks, I'm remembering that this is my image, which makes this my pre-image. My pre-image, let's remember, the pre-image is our starting point. The image is where we finish. This is also where we use the primes to show what the image is. The primes, once again, are just what I'm highlighting now, those tick marks, those apostrophes. So here, well, because we can tell which one the pre-image is on the left and the image on the right, we know that it's going from small to big. The word we use when it goes small to big is enlargement. So if something's getting bigger, it's enlargement. Alternatively, if we take something well, now look. Now in this example that I've just shown you, I almost messed up. The figure on the right is our pre-image, figure on the left is our image. Once again, we tell that because of those prime marks. What this is showing is we're actually starting with this triangle on the right, and it's becoming that triangle on the left. What's happening to it? It's shrinking. So we say it's reducing in size, or it's a reduction. If a figure is getting smaller, it's a reduction. If it's getting bigger, it's enlargement. That's a big piece of today. Ooh, I'm wiggling around real quick. So dilation, that's super important for today. The next thing that's super important for today is this term. Scale factor. Scale factor is this. The amount a figure changes by. Except it's not quite that. I also want to note we use the letter K. To show scale factor. So that's really important that you know that scale factor is the letter K. We are also going to use an equation to find the scale factor. If we take our pre-image, if we take a number from our pre-image and we multiply that by our scale factor, that's going to give us our image number. I say that and your head is spinning. I know. So let me stop it from spinning. I'll leave that on the screen. If I show you these two triangles, and if I tell you this little side is size 3, this bigger size is size 6, and if I say the one on the left is our pre-image, so we're going to the right, well, what's happening here? If that side starts at 3 and it's ending up at 6, we've multiplied it by 2. That gives you a hint. So I'm going to scroll down real quick. When I am talking here about this equation, which you should know, well, you will want to make sure you have it written down somewhere, preferably in your brain and on paper. Well, here, this is our pre-image. This is our image. So let's pull those numbers. We see 3 times k equals that 6. Well, if I want you to find the scale factor, I want you to find what k equals. To do that, all we have to do is divide both sides by 3, giving us k equals 2. This tells us our scale factor for these two triangles is 2. What that means is if I then told you, oh, this side, the other side here is 2, you could tell me, well, 2 times the scale factor, 2, 2k equals something, something. Well, we know k is 2. 2 times 2 equals 4. So this side would have to be 4. That was kind of a ramble, I know. Hopefully you followed. If not, vibes. What? Sorry, what? Another example. Here we're going to go in the reverse direction. So I'll keep the same numbers. If our pre-image is on the right, so we're going from right to left, what that means is when we set up this scale factor equation, which actually, let me go back and write that. This is our scale factor equation. Let's give it a name. Our scale factor equation, pre-image times k equals image. Well, here our pre-image is k. Is 6, right? Which means our image is 3. We solve by dividing 6 on both sides. Here k is 3/6. We can reduce that to be 1/2 or 0.5. And you can't see that. 1/2 or 0.5. So that's an expectation in this lesson is that you will be able to find that scale factor, that you will be able to use the information given and that scale factor equation to find the scale factor. If I asked you enlargement or reduction, you would say, think about it. This one is a reduction. We start big, we get smaller. We start big, we get smaller. If we go back up to this one, the first one we did would be an enlargement. Blah, blah, blah. Because we start small, we get big. The only other thing that I want to discuss is a trick. So we've talked about dilation, enlarge, reduce, and we've brought numbers into it with our scale factor. We can tell if there is a reduction or enlargement based on the scale factor. So if you know what the scale factor is, you can use that number to tell you enlargement reduction. This is what I mean. If your k number is greater than 1, then it's an enlargement. If this fancy thing, well, I'll finish. If we have this, it's a reduction. what that equation is saying is that k is between 0 and 1. This equation here is saying 0 is less than k, which is also less than 1. What that means is k has to be in the middle of those two numbers. That's how we get our reduction. Woohoo! So, example, if k is 3, well, is that going to be an enlargement or a reduction? Enlargement, because 3 is greater than 1. If k is 1.5, that's still an enlargement, right? It's still bigger than 1. If we have k equals 2/7, that's somewhere in between 0 and 1, so that's a reduction. Are you starting to see this picture? Starting to see what's going on. If we did, let's do this. If we did 10/8, we could simplify that to 1 2/8, so it's bigger than 1. If we did k is I'm trying to think of something that would be interesting. 0.4. 0.4 is between 0 and 1, so it's a reduction. I guess I'll say this. If k equals 1, the figure doesn't change. Oops. It's just like multiplying any number by 1, the number stays the same. Same idea here. If k equals 0, the figure goes away. When you multiply something by 0, it becomes 0. So when you say a scale factor is 0, you've poofed it into nothingness. Like the Thanos snap, in a way, scale factor was 0. Technically, I think his scale factor was 1/2, because half the people in the universe, half living things in the universe, went away. Anyways, to wrap up, ooh, look at all that work that we did. To wrap up, here's what's important. When we look at our practice, you're going to see the first section. All it asks is for you to look at those two figures and tell me, enlarge or reduce, what's happening. In the second section, questions 3 and 4, 2A, 2B, I want you to find the scale factor. So that's going to be k equals something, and tell me enlarge or reduce. That third part is just one question. Is dilation isometric? Why? So if you don't remember, check at the beginning of this video. It's like the first thing we talked about So, yeah, that's my hint on that one. There we go. Hopefully this is helpful. Pause, speed me up, slow me down, whatever to be helpful. But I'm calling it here. Good luck. See you next time.